in this example, they don't give us a function, but they do describe the function. They say that at 0, the function is -3, and the derivative of the function is less than or equal to 5. And what they want to know is how large can f of 2 be, just given this information. And it doesn't seem like enough, but if we apply mean value theorem, it actually can tell us a lot. So first of all, it gave us a derivative, and it said the derivative is less than or equal to 5. If they're giving us a derivative, then they're saying f of x is differentiable. Like I said, we're going to use mean value theorem, so that's one of the criteria we have to show. And if it's differentiable, then it must be continuous, because that is a restriction on differentiability, that it must be continuous to be differentiable. So we have both conditions now. And so then the third thing about mean value theorem, so by mean value theorem, it says that f prime of c equals f of b minus f of a over b minus a. So the average rate of change equals the instantaneous rate of change at a value of c. So given that information, and given the stuff at the top, we can start to find f of 2. So they're giving me 2 points to look at, so we can call this f of a, and we're looking for f of b. So let's plug that information in. So that means f of b would be f of 2. F of a is f of 0. And b is 2, and a is 0. And so we don't know what f of 2 is yet, but we do know f of 0 is -3. So we can plug in -3 there. And we can solve that as much as we can. So I'm going to get f of 2 plus 3 over 2. And that's as far as we can go, but they want to know how large can f of 2 be. So that's where we bring in this derivative is less than or equal to 5. Remember, we just found, they said the derivative is this. So we can say this derivative is less than or equal to 5. And now we can figure out more about f of 2. So if I multiply 2 to the other side, I get 10. And if I subtract 3 to the other side, I get that f of 2 is less than or equal to 7. And so that means f of 2 can be as large as 7.